I'm Kenneth Shifa, and this is my walkthrough for COMP3132 Assignment 3. In this video, I will quickly cover Part A, Image Convolution, then Part B, CNN Training, and finally my answers for question 3 to 9, including comparisons between the original model and deeper model, and a dropout model. Starting with Part A, I imported the image, converted it into a NumPy array, and then used it for one channel so I could apply 2D convolution kernels. Then let's go for question 1. Question 1a. I used a 45-degree line detection kernel. In the output, lines in the diagonal direction are highlighted more strongly than the other structure. Then for question number 1b, I used a 135-degree line detection kernel. This emphasizes the opposite diagonal direction, so we can see the kernel orientation directly controls what type of line becomes prominent. For question number 2, I applied the 3-edge detection kernel, each with output detects boundaries where pixel intensity changes, but with a slightly different edge sharpness and contrast. This demonstrates how kernel design changes the visual response. Now let's move on to part B. I prepared the fashion MNI ST dataset by normalizing image values to 0 and 1, range and hot encoding the label. The original model is a standard sequential CNN made of convolution and pooling layers, then flatten the dense layers for classification. For question number 3, the learning curves show signs of overfitting once training performance keeps improving while validation performance improves more slowly or starts to level off. Next, in question number 4, the model contains convolution pooling, flatten, dense, and output softmax layers. Question number 5, the roles are convolution layer extract visual features. Pooling reduces spatial size and helps generalization. Flatten converts feature maps to a vector. Dense layers perform final classification learning. And softmax output class probabilities. For question number 6, I built a deeper model by adding more convolution and pooling capacity than training it again. Next, let's go to question number 7. Um, for question number 7, compared with the original model and deeper model learns, we richer features and can improve performance, but it may also increase training time and risk overfitting depending on the validation trend. For question number 8, I added a dropout to deeper model and retrained. Compared with the previous deeper model, dropout usually gives a more stable validation trend and better generalization by reducing overfitting. As for question number 9, dropout works by randomly turning off a fraction of neurons during training. This prevents the network from relying too much on specific neurons and encourages robust feature learning. During interference, um, dropout is disabled and the full network is used. This concludes my assignment 3 demonstration. As I showed part A convolution outputs, explained question 3 to 9, and compared results from the original, deeper, and dropout models. Thank you.